G'day guys, we're back. Okay, so what I've done, I've hooked up one of my other panel meters here. It's the exact same model, just a different one. Instead of running it off of the clean output of the power supply, I decided it's not really a fair test setup because we're trying to find out what's causing the oscillation. So the oscillation could be a sort of LC resonance between the long wires and the LM7812 regulator and its output capacitors and the capacitors on this guy and its regulator having a sort of a seesaw effect. It could be the microcontroller, it could be down to a lot of different things. So I thought, well, yeah, I won't power it off the output of my power supply. I'll power it off of what it was originally being powered off of, the same as the other panel meter that's in the power supply. And this wire here is the sense voltage, right? Also coming off my power supply, because I want to take a accurate representation of what's going on here and reproduce it to measure it. So what I did first is I just got a normal scope probe, took the top off of it, made a little loop with the ground loop. I'll just turn this over so you guys can see the back, and I'll just show you quickly my scope. Right, you can see there's nothing on that waveform. Now if I take this little loop here and move it around where the regulator is, we see some high frequency content there. But if I move it to where the micro is, that's hard for you guys to see that, but there's a lot of high frequency content there. It's literally just sitting above the micro. So we'll move up on the time base. The spikes are so small that you can't really see them. Yeah. They're very short spikes that are riding. Yeah, they're basically riding on the mains ripple, but they're short, high frequency pulses. I don't know if you can see that. Let me just unplug the phone. I'll take it in a little bit closer for you guys. See all those spikes on that waveform? Now the phone light is actually cancelling out. Oh, it's hard. It's really hard for me to show you guys this. I'm really sorry. I think you guys can see those spikes, but so we now know that the source of the noise is the microcontroller. So I'm going to have to change some things around here. What I'm going to do is I'm going to set up to put this on the board and take some different measurements. Alright, I'm back. So what I've done, I soldered my oscilloscope probe over. I didn't want to put it directly over the capacitor on the output of the regulator because it's going to have a little bit of a filtering effect. But there's a spot here that's literally in between the rails, the positive rail and the ground plane from the regulator to the micro, so I put my scope probe there. And if we come over to the scope, sure enough, it's terrible too. As you can see, I'm at 50 millivolts a division. And look at that. Look at all that ringing. See if I can turn the flash off. There you go, guys. So that's the oscillation that I've been talking about. That is coming from the microcontroller. and it's going back into the regulator. So that's what I'm going to work on. I'm probably just going to have to add some filtering to it. I don't think it's going to be too complicated. So I'll do that, and then I'll upload another video showcasing that. Someone also asked me what frequency it was oscillating at. I'll take a measurement of that too, and I'll post all that in the next video. I'm trying to keep the videos short because I don't want to make them too long and bore people, but I want people to also be able to get a view of what's going on and understand how things work at the same time. So I'm trying to meet in the middle there. Anyways, I'll be posting an update very soon.